Okay, girls, so this is the second lesson in the section dealing with forces. So I'm in our class notebook and I'm looking at forces, lesson 2, pages 11 to 16. I'll minimize that, increase the view, and we're starting on page 11 and we're starting with representing forces. Okay. And again, this is not going to be new to you. These are things that we've done previously. And so what we've looked at is how do we represent a force on paper. And basically, you know that when we draw this on paper, we use an arrow to represent the force. And we always show forces acting from the center of the object on which it acts. So here's an example, soccer ball being kicked along or being pushed. And you'll notice that the arrow is drawn from the center of the ball to the right in this case. Okay. So the direction of the arrow is the direction of the force. And the length of the arrow is basically an indication of the size of the force. So if I wanted to show a bigger force acting on that ball, I would then go along and just draw an arrow that's longer. We're not concerned about the thickness of the arrow. It's really the length of the arrow that gives us an indication of the size. So you know, of course, that we can have more than one force acting on an object. Okay. Here's an example of this boy's arm being pulled, 10 newtons being pulled to the left, 6 newtons being pulled to the right. And what we've spoken about in the previous lesson is an example of taking that and putting it into what we call a free body diagram. Okay, so this boy in the middle, his name is Rod. And so that would be Rod over there, represented as a dot. You've got 10 newtons being pulled to the left, 6 newtons to the right. And if you work out the net force, 10 minus 6 equals 4 newtons to the left. So the net force or the resultant force will be in the direction of the bigger force. Okay, that's page 12. We get on to page 13. So if you imagine you are pushing someone in a go-kart, your friend comes along to help. That means the two of you, your two forces together, will provide a bigger force. So those two forces will be acting in the same direction. Okay, I'll just highlight that. So these forces acting in the same direction to produce a net force, and the net force is going to be the sum of the two smaller forces. So you'll see on the diagram that one's been labeled F1, F2, and those are just labels we give to forces. So when we represent that in a free body diagram for now, there's F1 and there's F2. Okay. We spoke about a spring balance, which is just an instrument we use to measure a force, and that I did in the previous lesson. We then get on to different types of forces, and this particular activity we'll have to come back to at some point because it's about working with magnets and paper clips, but I'm sure you've got some experience of magnets. I'm sorry about the next page. I had to copy this as an image, so it's a bit blurred in this version that I'm looking at. But the two types of forces that we talk about, it's very simple. There's a contact force and a non-contact force, and we're going to be talking about this in more detail. And if you think about the words contact force, basically you need objects that are in contact with each other. and they exert forces on each other. For non-contact forces, objects which are not in contact, and they exert forces on each other. And let's think about examples of non-contact forces. I'm sure you've played around with magnets. And when we've dropped things like our tennis balls, apples from a tree falling, that force due to gravity is a non-contact force. There's also things like lightning, and that's an example of what we call electrostatic force. We also refer to that as the electric field, which we'll get to in more detail. But those are non-contact forces, which we'll come back and look at. For now, let's look at contact forces. And the one that is going to become really important for us is this force of friction. And again, I'm going to go through it very quickly because we spoke about this in class a number of times. And the definition we want to use, the force of friction is a force that's always going to oppose the motion of an object. So friction will be opposite to the direction of motion. Try and remember that. So if we go back to the ball, let's scroll up and find this ball. If the ball is moving to the right, then the force of friction, let's go here. That will be my force of friction because it's in the opposite direction to the motion of the ball. Okay, let's go back down. So friction is an example of a contact force. And why? Because you can only have friction when two surfaces are rubbing up against each other. Okay, so there was the example of the ball. We come back to the go-kart. You've got the two forces being applied by the two people pushing on the cart. And then there's a question, what other forces will be acting on this cart as it moves along? Well, the one force will be the force of friction, and the other force is the weight. This object here, or this dot, represents the go-kart. Okay, so in this free body diagram that we're looking at, those are the two forces, and we typically talk about those as being the applied forces. But for us, those are the pushing forces being applied. So there's friction and then there's weight. Okay, and then there's one last force that we're going to end off with. And this is what we call the normal force. And I want you to really concentrate and think about this very carefully, because this completes the force diagram we're looking at. So there's another force acting on the go-kart. So when you're standing on the ground, you feel the ground beneath your feet. Okay, if the ground was not there, you'd basically continue falling. So there's actually a force that's preventing you from falling any further. And that force is called the normal force. And this is a very important definition. Normal force is always perpendicular to the surface that the object is resting on. What does perpendicular mean? 90 degrees. And so this angle there is 90 degrees between the surface and the object. And the normal force is that upward force on the object. So it's the force that the ground is exerting on the object. So if we read that again, the normal force always acts perpendicular to the surface that the object is resting on. And so if we go back to our go-kart and we want to complete our free body diagram, That's our normal force, that's our friction, and that's our weight. And we've got two other forces pulling along to that. The last thing I want to pick up on is, instead of using words in a force or free body diagram, we often use symbols as well. And you can see up here, there's a symbol there for normal force, and there's a symbol there for weight. And so instead of writing the word normal force, we typically sometimes have F subscript capital N. This would be F subscript small f, force of friction. And this would be F capital W for the force of weight. Or we sometimes give it a small g for gravity. And so that's your free body diagram. We're going to stop at that point, and the notes then continue in lesson 3. We'll pick up on that.